All right, quick test. And yes, okay. So today I'm going to go through inversion of control. And how does it work? Inversion of control is not so much a design pattern as it is a principle. It's a principle that a lot of design patterns are built on. But before we can really get to understanding inversion of control, we have to cover just a few prerequisites because one of the things with inversion of control is if you're going to invert something, you have to have a normal flow of control. Inversion is when you reverse something or turn it upside down. So we have to understand what the normal flow of control is first. And this picture will be relevant. I'll come back to it later. So let's talk about a domain and layers and references. So domain can be defined a lot of different ways, but for the purposes of inversion of control, we're just going to think of it as collections of related classes. And there's a lot of different places where domains get kind of defined. They can happen at many different resolutions. Um, but basically, it's here's a whole bunch of classes, and every class should always have a single purpose, and then this group of classes should have a larger purpose. So just a quick some examples of a domain. If you're going to use an external library, you can usually think of it as a domain. So like the JSON serializer, um, that's a domain. And you might have different layers in your application. This is also generally different domains. So if you're using the model view model pattern, then all three of those are going to be different domains in your class, in your application. Um, if you have kind of following clean architecture and you have sort of your infrastructure layers on the outside, those are different domains. And then the layers inside are different domains. You can have sort of hierarchies and different resolutions of domains. And so what I mean by that is if we take the Newtonsoft JSON example again, you can think of that as one domain, and that's probably sufficient if you're just using the library. But inside the library, they actually have multiple domains. So they have a tokenizing domain, which is all about taking in the input from a string and turning it into a bunch of tokens, J objects and J tokens that represent sort of if you come from the XML world, it's like your DOM, um, but it's an in-memory or an abstract syntax tree if you're coming from the parser world, but an in-memory representation of the JSON string. And then they have a domain that's built on top of that, which is the data binding domain. And so they can take those tokens and then bind them into the classes that you provide. Both of those domains are within the Newtonsoft.json domain. So it's kind of a loose term that can get sort of thrown around. You know, domains can eat other domains. All right. Class libraries are typically thought of as domains. So I kind of covered that. Class library might have multiple domains. Covered that. And every application has at least one domain, which is the application domain. Um, I probably shouldn't call it that. Um, it's that has special meaning in C# for something completely unrelated. But if you think by application, I mean when you write an executable or when you write a web server, something along those lines. And then there's a domain which is whatever that purpose that application is supposed to do. So if you were going to write grep, then you would have a grep application, and the domain for the grep application would be all of the classes that you need to make grep work. Um, Layers are the boundaries between domains, and references are the connections between domains. And so here's the important thing, is that references go in a single direction. Um, your code references newtonsoft.json. Newtonsoft.json does not reference your code unless you happen to be, I think they have one reference on some kind of math library. Um, Now that math library does not reference newtonsoft.json. So your references are always going in one direction. And again, if you think about your layers, so model view, view model, your view references your view model, and your view model references your model. Um, if you have your clean architecture, your infrastructure layers, your outer layers will reference your inner layers. Um, and so that's where we get our direction from. So this here's bad. We have circular reference between two different domains. That's not two different domains. That's one large domain with a bunch of space shoved in the middle of it. Here we have kind of three different domains. And so, you don't have to have a single reference from a domain to another domain. You might use Newtonsoft.json in a lot of different places. Your controllers, each one is probably calling into some kind of inner layer in your onion architecture. Your view is calling into your view model, a bunch of different places, but all of the arrows have to be going in the same direction for it to kind of work. So now that we've gone over kind of these fundamentals here, we can talk about inversion of control, because when we talk about control, um, we're talking about calling a method. And so I have a bunch of examples here of normal control. Um, so we're in our application and we call into Newtonsoft.json and it returns. This is normal control. Um, so normal control is if you're going to call a child reference, then you're going to go in the direction of that reference. So back here, if this class here makes a method call against this class here, that's normal control. And if this class here makes a method call against this class here, that's normal control because we're going from the parent domain to the child domain. We're going in the direction of the arrow. So now we can understand inverted control or inversion of control is when we're going to go across that arrow backward. So that's when the child domain calls a function in the parent domain. And we'll go over how that happens in a minute. So a couple more examples. If we're in the app domain, we often call into the data access domain. Um, if we're in, can be kind of the same thing. We're calling into some kind of API client domain. And here is we're looking at the actual function that gets called because we don't really ever see the view code in a MVVM. So this is WPF example where the view would call into this function here in our view model layer. I guess this is the code behind, which you may or may not consider as part of the view model, but same idea where we're calling down into our layers. All right, so inversion of control, why would we ever want to use it? It makes things a lot simpler. So hopefully by the time we get to the end, this will all make sense as to why this is. But if we don't have inversion of control, then our APIs tend to be more complicated. Um, a lot of the early um, OS APIs, so your kind of standard libraries from Linux and Windows, didn't use any kind of inversion of control. And a lot of them still don't, and they are often seen as very complicated. Um, Inversion of control can allow someone to create a domain. Yeah, so when you're, um, what I mean here is when you're writing this child reference, you know that you're going to be used in a lot of different places. You can use inversion of control to kind of customize how you operate in the same way that you would use parameters. And so we'll see how that happens as we go through. Yeah, model view controller, dependency injection, observer pattern, reactive programming events. All of these things are either implementing inversion of control or rely on inversion of control heavily. And it's one of the major drivers for creating interfaces. So generally, I have two rules for creating interfaces. One of them is if you have two implementations of something, um, then you need an interface. And if you already have two implementations of something. The other case where you want to use an interface is when you're doing inversion of control. And we'll see that happen as we're going through here. So let's go ahead and start with an example. This is some output from running git log. It's not terribly interesting. And we have Amy. Amy's working at some kind of company, and they want her to publish release notes as development goes on. And this is some kind of made up example. But basically, the idea is anytime something changes in the Git repository, we want to use our log statements to create release notes. And so when someone makes a new commit, that should automatically go into our release notes, and our release notes should automatically be pushed onto some external site. Um, Certainly a lot of better ways you could probably solve this, if you were using Git hooks, or I'm sure there's some things built into the Git log function to change the functionality. But one of the problems Amy has is she doesn't like all of this output, just wants something more like this. So she writes a program that calls Git log every 20 minutes, and whenever she finds a new update, she parses out the actual message of the update and then appends it to some kind of file and notifies some web service somewhere that that file's been updated, so it gets republished. Um, so this program took a while to write. It's working. I think I covered everything here. Oh yeah, and the way her program works is it just dumps this thing to the console, possibly redirects to a file, and so um, that file is just, I guess, live, always getting viewed on the web or something like that. So that's the program that Amy wrote to parse this git log statements. And we don't need any inversion of control at this minute because right now there's only one domain. It's a bunch of files. It's all in the application domain. Um, and what this domain does is it calls git log, parses the output, writes it to the console. So our problem is when Frank arrives and he's heard that Amy has this nice program, but he doesn't want to just dump it to a file. He wants to update an RSS feed. Um, that's kind of it's just, if you haven't heard of it, it's just some kind of XML web structure. It's what's used to usually just by podcasts these days, so that podcasts can know when new episodes have come out or something like that. I guess it's probably used in the background several other places. We just don't know. Um, but Amy doesn't want to really have to deal with RSS feeds. She doesn't want that to go inside of her code. So she and Frank talk, they work together, and they kind of come up with this new design here where we're going to take Amy's application, which was these two boxes, and we split it now into two different domains. We have Amy's application domain, which does the stuff that Frank doesn't care about. So it does all the command line parsing, because Amy used to have, I think I skipped over this. Amy's program takes a few command line arguments to control max line length and things like that. Frank's program is I don't know, it's running in some different way. There's no command line arguments. He just determines them from a configuration file. So application domain contains the command line parsing, um, and it also contains printing to the console. The log parsing domain will be calling getlog every 20 minutes and doing all of the actual parsing of that output. So if we go with regular control, it's certainly possible. Um, Frank basically just has to call log parser to get log messages, and that will return the list of log messages. So you could imagine you call log parser to get log messages. It goes, calls get log, parses all of that output, and returns it. But one of the things that Amy's application did that was nice was that every 20 minutes it would call get log. So with normal control, Frank would either have to create a scheduler and do that every 20 minutes thing himself, but he doesn't want to do that. So they agree that we'll just have get log messages block until the next log message arrives. You end up with code that looks something like this, which is still normal control. Frank basically has this while true loop in his code here. call get log messages and add those to the RSS feed. And then go back to call get log messages again, and this time it will probably block for about 20 minutes. Maybe longer, because maybe after 20 minutes there are no new log messages. So this just blocks for a very long time. Eventually it will return. We'll add those back to the RSS feed. Frank's still not really happy because he has to, this loop is going to be running forever. So Frank has to spin up a thread in his application, which is devoted entirely to grabbing out these log messages and adding them to an RSS feed, which is not terrible, but it makes him grumble. And he grumbles enough that eventually Amy gets tired of it. And so they decide to use dependency injection, which is a form of inversion of control. Amy creates an iMessage handler interface. What should we do when a message arrives? Frank implements that interface here on message. I want to add it to the RSS feed. So now when that log parser object gets created, one of the parameters, possibly a constructor parameter, takes in an iMessage handler, Frank's message handler, and then Frank can just call start. He doesn't have to worry about it anymore. Amy owns the thread that's continuously running every 20 minutes, or maybe Amy's decided to use tasks or something like that in some sort of scheduler, so there's not one thread that's running for 20 minutes. Frank doesn't care how Amy decides to solve that problem. He just knows that whenever a new message arrives, on message will get called. Amy could even change to using some kind of Git hook that makes a call into her application, with a socket or HTTP or something like that to trigger that a new message has arrived. Frank still doesn't care. Frank is just sitting here and his on message will get called whenever a new message arrives. So why is this inversion of control? It's because somewhere in that log parser, it's going to call on message. And when we call on message, so when we're in the log parsing domain and you call on message, well, Frank's implemented the on message method. So we're in here in the log parsing domain and we're making a function call in Frank's application domain. And so that's inversion of control. And all right, so a few facts about this style of inversion of control, which is dependency injection. The interface is defined in the child domain. So here, the iMessage handler interface, that interface is defined here in the child domain. The implementation is defined in the parent domain. Frank's message handler, this class here, is the implementation of that interface, and that's defined in the parent domain. So that gets around, if we talk back up here where we talk about references and having one direction, this is how we kind of get around that problem where your child domain calls something in your parent domain without ever having a reference to that code. It's because the child domain is making a call against some interface defined inside here, and the implementation is over here. So that's how we cross that boundary. We're using an interface to cross that boundary. You could use a base class as well. Amy could, instead of creating iMessage handler, she could create, abstract message handler or base message handler, some class that she expects Frank to extend. This is usually not a good idea because it tends to just make things more complicated. There's, in order to extend anything, you really have to understand how the parent works before you're going to go extend it. And beyond that, you it limits your options. You can't have multiple parent classes. It's going to give you some kind of inheritance hierarchy, and so you're limiting whoever's calling into you their options, and you don't even know this person a lot of the time. So not a good idea. You want to be friendly, and just use an interface. Now, that's an almost always. There are um, things you can do. Sometimes you can have an interface and a base class saying, here's what I need. I know it's really hard to build one of these interfaces, so I've also built this base class which helps you to build that interface. You see that pattern a lot, and there are places where a base class is used. I was just using um, the .NET Core stuff to build a web application, and in their integration testing, um, they use a base class for this kind of inversion of control. And so it can work, but usually you want to just go ahead and use an interface here. The child domain always receives the implementation through some kind of injection. It doesn't have to be constructor injection. It could be setter injection, which means that you would create the log parser and then it's called set message handler on it, and you're injecting your implementation into it. It doesn't really matter what type of injection it is, but we've defined this interface in our child domain, implemented it into our parent domain, and then injected the implementation into our child domain. No need for dependency injection containers. So dependency injection containers are often called inversion of control containers. Um, and those containers are not necessary for doing dependency injection. They're not necessary for doing inversion of control. I'll touch on those briefly, perhaps at the end here. So using this dependency injection and an interface, we can accomplish inversion of control. But now the problem gets more complicated. Amy improved her library, so now it monitors for all of these different things. Branch created, branch destroyed, fork created, fork destroyed, merge happened. And you'll notice that these handler interfaces are starting to pile up. There's an iMessage handler, an iBranch created handler, iBranch destroyed handler. There are different approaches that you could take which are equally unpleasant. So you could merge all of these into sort of one iEvent handler interface, which has 1, 2, 3, 4, 5, 6 different methods on it. But Amy noticed that a lot of the times the people that were using her code only really cared about one particular event, so she didn't want to go down that road because then it's kind of weird if you have to implement an interface, but half the methods you just throw an exception and say you don't handle that. Constructor injection before, Amy just had the maybe message handler come in when you were constructing the log parser. That's not working anymore because you don't want to pass in 6 different implementations into a constructor. That's just going to look like an ugly constructor. And a lot of these are starting to look very similar. They're all one method. They all take in some kind of parameter. And it was starting to get even more complicated because people were wanting to add multiple implementations of an iMessage handler. So, some parent domain said, I have like 5 or 6 different places where I want to do something when a log message gets sent out. So I'd like to be able to add a list of these, which you can do. You can define it as a list, but that's again more work, and now that work has to be repeated for each of these different handlers. So there's another pattern. Amy realized that so all these handlers are following generic pattern. She starts to implement it, but then she realizes that events already exist for exactly the purpose. So now our log parser, instead of having a reference to some kind of interface that gets injected in, defines publicly 6 different events. And all of these events map to the different things that can happen. A message has arrived, a branch has been created, a branch has been destroyed. And that's another type of inversion of control. So let's go ahead and look at it. Events are nothing magical. And the way an event will work is in the log parser, Amy's writing code. She realizes that a message has arrived. She checks to see if the event handler is null. And if it isn't, then she calls a method basically saying dispatch event, giving the message that arrived. When you call dispatch event, all of the event handlers will run, and then control will return. So when you make a call to dispatch that event, you transfer control over to all of your handlers, and then control returns back. So if we think again about Frank's class, and Frank wants to now use this new API here, Frank's message handler becomes an event handler, and he registers that event handler with the on message event. Um, so in Amy's code, when she calls dispatch event with that log message, it's going to go off and it's going to run Frank's code before it returns from that call to dispatch event. And so again, we've inverted control here because Amy says dispatch event, and then control transfers to the parent domain, which handles the event. Um, so there's nothing magical about events. They're just syntactic sugar around dependency injection. They're basically the same thing as what you have here, except you want to have a list of these. It gets hard to keep track of. So events take care of keeping track of all of that for you. It leads to code that's a little cleaner and simpler to understand. One thing with events, though, is that you usually don't return values. So if you care about the return value, this isn't going to work. In our case, we don't really care about the return value because we're just saying, hey, these things happened, go do something, and then come back. Um, and I have a case where we would care about the return value. Um, yeah, let me talk about it now. So in um, going all the way back to our JSON library, and I use newtonsoft.json a lot only because it's the most popular NuGet library, so it has the highest chance of people having used it before. But in this library, one of the questions can come around, how do you serialize an enum? Do you do it as a number or as a string? And so newtonsoft.json has a concept of I think it's called a type converter, but it's an interface that they define, which basically says, if you give me a type converter, then whenever I run into a particular type, I will call your type converter to convert it into some other form that you want me to serialize. And so you can use this with enums. By default, if you say deserialize object and you pass in some enum, it's going to deserialize it as a number. If you want a string, you create a type converter saying, hey, when I ran into this enum um, of type response code or something like that, then use this type converter, which will return a string value instead of the number value. And here we couldn't use an event. Newtonsoft.json couldn't say, have an enum encountered event where you then convert it, because Newtonsoft.json really cares about that return value. It's going to take what you return from that type converter, and it's going to then resume turning that into a JSON format. And so that's an inversion of control because Newtonsoft.json is calling into your type converter in your parent domain. And it couldn't really be done with an event because we want that return value. We care about that return value. All right, events can typically have multiple subscribers. And so I kind of mentioned this as I was describing it as well, which is you could, with dependency injection, have multiple handlers. But usually with dependency injection, you're thinking sort of one implementation. And with events, you're always having multiple subscribers in mind. That's just a pattern that happens to go. And yeah, events are just a special case of dependency injection. No one will ever call it that. If you say it that way, they'll probably think you're weird. So just be careful. And while I was kind of reading up on events to create these slides, I ran into one very interesting case, which we'll call inversion of control inception. So I did mention that events can't return values, but one problem where we sometimes do want that return value is if we want an event to be cancelable. And so I saw this implementation here, which basically said, oh, Well, in your event parameters can be an object which has a cancel method. So you can say, you know, when they're implementing it, they'll say, okay, on message, I look at the message, and if it has the word merge in it, I want to cancel it. So I call this event.cancel method here. And this, what we're doing here is in our child domain, we define the event. Logic passed to our parent domain, going backward. Um, so now we're in our parent domain in our event handler implementation, and we call cancel, which is this standard interface we've defined here, and it's sort of inverting control back to our child domain. Um, so inversion of control is not really like a clear-cut concept, but we're doing some, you can do some interesting things with it. And then, cancel method will run over here in the child domain, control returns. So this, I would consider it a case of inversion of control, even though it is following that normal parent-child relationship because it's doing it in this strange way where you're calling a method on something that the child has defined. All right, other ways to invert control: observer, reactive, and delegates. I'm not going to go over each of them in detail. It's again going to be following kind of the same type of pattern. Observers and events are really kind of the same thing. Reactives and observers are often thought of as kind of the same thing. Delegates, if your dependency interface only has one method, you can use a delegate. Again, a delegate is just a kind of dependency injection. It's observer pattern, reactive design pattern, similar to events they can be used for inversion of control. All of these things, dependency injection, observers, reactives, events, could be used for reasons other than inversion of control as well. Is that true? Maybe that's not true. That's an interesting question to try and think through. Um, Certainly, I think for the observer and reactive pattern, but maybe not. We'll just pretend I didn't say that. All right, when to use inversion of control. So probably the right answer is just whatever it feels like it's right. Um, and kind of going back here, if we weren't calling it every 20 minutes, then the normal control implementation wouldn't really be that bad. You just call get log messages, it returns a bunch of log messages. Um, but again, the inverted control method isn't that bad either, where you just have that I message handler. So both could be very viable. And when to choose one over the other, and just kind of takes, to some degree, it's just you have to pick which one feels right. But there are some cases where normal control definitely doesn't work so well. Um, so when the child domain owns when something needs to happen, and this will often happen when you have sort of two flows of control in your application that collide. So back with our Git example, there's some kind of thread in Amy's code which is calling git log every 20 minutes. You can think of that as a flow of control. It's a whole different thread. It's this whole thing that's going on and calling git log every so often. Then Frank's application is doing its own thing. It has, maybe it's a WPF application, so there's the event loop thread, and that's where the main flow of control is going. And then this layer between the two is where these two flows of control kind of collide into each other. And so that leads to this case where the child domain knows when something has to happen. And so um, it gets, uh, it would get complicated for regular control to happen. Because if the child domain knows when something needs to happen, and it's in the child domain's kind of flow of control, it's just a lot cleaner if the child domain can just make that method call. It can call a message happened rather than doing this sort of polling thing
where Frank is polling for messages all the time. Now, you see this, I talked about OS libraries. Um, OS libraries tend not to use inversion of control, and it'd be an interesting question to kind of see why. It might just be that they were written a long time ago. Um, and honestly, the standard library wrappers that C Sharp has around a lot of the things might not be, they might actually start using inversion control now. But I'm thinking of if you ever written any Linux OS code or COS code with IO, there's the select, which is very much that old style where you have your thread dedicated to using this select structure to figure out when an event has occurred, and you have some kind of thread that's dedicated to pulling that select structure to look for events that have occurred. And then when that event is discovered, then you call. So like if you are reading from 2 or 3 files, you can create this select loop where you go while true, um, wait for the reader to finish populating, getting the stuff off the disk and into memory. And then when that's happened, then you call read to actually grab the stuff. Um, so that's a case where it would seem to be a lot simpler if you went to read a file and you just passed an event handler, which is actually how the JavaScript file reading happens. Um, Saying basically when data arrives, call this method, and then I'll take care of it. So that's an example where it seems like inversion of control is the simpler approach to go when the child domain owns when something needs to occur. When the child domain needs to return to the parent domain in the middle of some sequence of operations. So this is that Newtonsoft.json example I had with the enum serializer. When you are serializing an object, you're kind of doing this tree traversal visitor pattern type thing where you're going through the object in maybe a depth first search pattern, and you get to the enum way deep in the object somewhere. You need to call that type converter to handle that enum, and then you need to keep traversing the tree. It would get very weird if you went through, you hit an enum, and you said, oh, okay, well, return from this method, and then say, I returned early because I hit an enum that I need help processing. The parent domain then processes that enum and then calls resume loop or something like that. So there are ways you can do it, but it would take one operation and it would split it into 2 different operations because you'd have all the stuff that happens before the enum, then you return, and then they call resume. It's just a very strange way to code that. So that would be another way that you can do inversion of control. And so one place where I kind of see, no, it's not a good example. And it's not always very clean cut. You may not, again, it's not a formal pattern. So it doesn't, if something seems like inversion of control, it's just good to know that. You don't have to do anything differently. It's not a formal pattern. Sometimes it can be a little confusing. And sometimes it doesn't strictly follow these rules either. So frameworks tend to be a little backward of what you might think. So usually when you're thinking about these domains and references, you're thinking that this domain here has a project reference to this domain here. And by a project reference, I mean like an actual reference that you would add if you're using Visual Studio into your list of references, or if you're using .NET Core, you'd say .NET add reference or .NET add package, like a formal reference to the code. Frameworks are strange in that the child domain references the framework. So usually with a framework, um, let's think of the MVC framework and controllers as an example, or actually probably the WPF is better understood. Um, WPF is our framework. Our application references the framework, but all of the calls, the normal flow of control, is going from our view into our view model. So even though from a code perspective, your application references WPF, from a inversion of control perspective, the normal flow of control is from WPF into your application. Um, and so you can't always rely on the package references to tell you who's the parent, who's the child in kind of your normal flow control relationship. But usually if it's inverted like that, it's always, that's kind of the definition of a framework for a lot of people. Um, a library is something you reference and then you call into it. A framework is something you reference and then that framework calls into you. But all the normal inversion of control rules apply. So like with WPF, if you're following the MVVM pattern, you're using inversion of control a lot because your view model is supposed to be all observable fields which get bound to your view. That's a type of an inversion of control. The view is the parent, the view model is the child. All of these properties are observable, and when they change, they get updated in the view. And if you think about why does it have to be that way, we'll run into our original list of why use inversion of control again. So let's think about that for a second. If we have our view here and our view model down here, why does that control have to be inverted? What would normal control look like? Um, Normal control would look like when a button is clicked, I call something down in the child layer, and it returns some value that I use to update something, but we don't know what to update where. Um, and so that would get somewhat confusing. Um, for example, when there's a button click, maybe we want to update three different things over here in our view model, which correspond to three different things over here in our view. It's not obvious how you would make that happen. And there's no reason you couldn't flip this dependency where you have the view model that references the view. And when something needs to change, the view model would call into the view and make that change directly. You can write code that way, but that's generally undesired as well, because if you decide that you want the reference to go the other way, where the view model is the parent and the view is the child, then the view model becomes impossible to test because you can't mock out the view very easily at all. Um, so um, that was, and another reason that you might want that inversion of control also is because there are things that can happen in the background in the view model's own flow of control, which cause the view model to need to update. So the view is over here running its event loop. It might never know that some scheduler over here decided that, hey, I need to go check and see if the widgets are still busy. It says, oh, they're not busy anymore. So let's change some view model properties so that we know that um, some buttons should be re-enabled over in the view. We have, again, one flow of control over here, which is checking every 5 minutes or so if widgets are busy somehow. And we have our event loop over here, and those two flows of control merge, so we're using inversion of control to communicate between the two. Um, and so finally, we can go back here, and we can see why this picture makes sense. We have Spider-Man as our parent domain. Spot is the child domain. We're going to normal control originally. Spider-Man makes a call against Spot, and then Spot is processing that call and decides it needs to do an inversion of control and make a call back into Spider-Man. And so we have inversion of control. I hope this left you less confused and not more confused, but more questions are not always necessarily a bad thing. Thank you for listening.